Alright, we're going to graph 3x squared minus 3x divided by 2x squared minus 3x minus 5. What I like to do first, I like to find the vertical asymptote. I just set the denominator equal to 0, where I'm going to have to factor this. So I'm going to use the Lizzie's method. That's negative 10, negative 3. What two numbers multiply to get negative 10? Add to get negative 3. That's negative 5 and 2. And you can't forget to divide by your a term. And so that's x minus 5 halves and x plus 1 equal that to 0. Then my vertical asymptotes are x equals to 2.5 and x equals to a negative 1. So after I find my vertical asymptotes, I'm going to go ahead and I'm going to find my horizontal asymptotes. So let's go ahead and do this. And to find the horizontal asymptotes, well, that you have to use the rules, and that's something that you guys should have memorized by now. But since the degree on the top is equal to the degree on the bottom, we just simply take the ratio of the leading coefficients. So my horizontal asymptote is 3 over 2, and that's equal to 1.5. Now let's find our y-intercept. Well, y-intercept, we just let x be 0. So if 0 minus 0 over 0 minus 0 minus 5, that's 0 over negative 5. That's equal to 0. That's my y-intercept. Now let's find the x-intercept. Well, we just set the numerator equal to 0. Well, factoring out this, I have 3x and x minus 1 equals to 0. So x equals to 0 and x equals to 1. So I have everything in place. I have my vertical asymptotes, I have my horizontal asymptotes, I have my y-intercept, and I have my x-intercept. Now I can graph it. What we should also do is set the function equal to our horizontal asymptote to see if it's going to cross anywhere. Well, I have 3x squared minus 3x equals to 3 halves times the denominator, because we just simply cross multiply. So I have 3x squared minus 3x equals to 3x squared minus 9x over 2, and that's minus 15 halves. 3x squared will cancel. I'm going to add 9x over 2 to the other side. So this is negative 6x over 2 plus 9x over 2 equals to negative 15 halves. I have 3x over 2 equals to a negative 15 over 2. And by multiplying both sides by the reciprocal, x equals to negative 15 over 2 times 2 over 3. And this is going to be equal to a negative 5. So the graph will cross the horizontal asymptote when x is equal to a negative 5. Alright, so we're ready to graph. Vertical asymptotes at 2.5 and negative 1. And at negative 1. The horizontal asymptote is at 1.5. So like right there. It will cross at negative 5, 3, 4, 5, and that horizontal asymptote. The x-intercepts are at 0 and 1. 0 and 1. crosses here. The y-intercept is at 0. We already have that plotted. And then we just pick points. Now it's only going to cross the horizontal asymptote at this one spot, and it can't cross anywhere else. So in the middle, I know that it's not going to cross this line, and it can't cross the vertical asymptotes. So I know it's stuck here. It has to go through the x-intercepts, and it's stuck because I can't go past the horizontal asymptote. It's the only place where it's going to is in this spot when x is -5, and this is that spot right there. All right, so let's see. So pick a point to the right of the vertical asymptote on the right. Let's choose f of 4, and let's see what happens when I choose f of 4. Well, f of 4 is equal to 12 fifths, which is 2 point something, and that's above the horizontal asymptote, and I'm stuck there because I can't go past the horizontal asymptote anywhere except for when x is -5. So why don't we pick a point that's to the left of -1 that's not -5. Let's pick -2, for example. F at -2 is equal to 2. So I'm starting it off above the horizontal asymptote in this region. Now it's going to cross there, but it has, since it's an end asymptote, it has to come back towards that line. It goes through it, but then it has to come back towards it, and it never crosses it again. It only crosses it at that one spot.